Imagine building a professional COVID dashboard that businesses pay thousands for, except you're doing it for free in just a few minutes, using nothing but Python. Sounds impossible? Stick around, because by the end of this video, you'll have a fully functional data visualization dashboard that would impress any hiring manager. Here's the reality. Every company today needs data visualization skills. Healthcare organizations track patient outcomes. Tech companies monitor user behavior. Even restaurants analyze foot traffic. But here's what they don't tell you. The tool powering most of these dashboards isn't some expensive enterprise software. It's Python. Open source. Free. And you're about to master it. The project setup. What we're building today. Today's dashboard features. Real-time COVID-19 case tracking across multiple countries. Interactive line charts showing infection trends over time. Bar graphs comparing death rates and recovery rates. Geographic heat maps visualizing global spread. Customizable date ranges for specific analysis. Export functionality for sharing insights. First, let's import our essential libraries. Pandas handles our data manipulation. Think of it as Excel on steroids. Matplotlib creates our visualizations. NumPy helps with mathematical operations. And Requests fetches our COVID data from the API. These four libraries are the backbone of any data science project. Python imports for COVID dashboard setup. Pandas, aliased as PD, handles data manipulation and analysis, powerful data structures for working with structured data. Matplotlib.pyplot, PLT, creates visualizations and charts, the primary plotting library. NumPy, NP, provides mathematical operations and array handling, essential for numerical computing. Requests fetches COVID data from APIs, HTTP library for making web requests. Datetime imported for handling date and time operations. Configuration sets Matplotlib style to Seaborn Darkgrid for professional aesthetics and Pandas display options to show all columns without truncation. Now comes the exciting part, fetching real COVID data. We're using a free API that provides up-to-date statistics from Johns Hopkins University. This is the same data source used by major news organizations worldwide. The beauty? One line of code gives us access to millions of data points. Here's our data fetching function. We hit the API endpoint, parse the JSON response, and convert it into a clean Pandas data frame. Notice the error handling. Professional code always accounts for network issues. The try except block ensures our program doesn't crash if the API is temporarily down. Function to fetch COVID-19 data from disease.sh API. Uses try except block for error handling to prevent crashes from network issues. URL variable stores API endpoint for country-level COVID statistics. Requests.get makes HTTP GET request to fetch data. Response.raise_for_status checks for HTTP errors and raises exception if request failed. Response.json parses JSON response into Python dictionary. PD.dataframe converts dictionary into Pandas dataframe for easy data manipulation. Returns dataframe if successful, none if error occurs. Request exception catches all request-related errors. Print statement logs error message for debugging. Professional pattern for API data fetching with proper exception handling. Raw data is messy. Always. We've got missing values, inconsistent formats, and columns we don't need. This cleaning step is where 80% of real data science work happens. But don't worry, Pandas makes it simple. We'll select relevant columns, handle those pesky null values, and format everything perfectly. This is our data cleaning pipeline. First, we select only the columns we care about: country, cases, deaths, and recovered. Then we drop any rows with missing values using dropna. Finally, we sort by total cases to identify the most affected countries. 3 lines of code, and our data is analysis ready. That's the power of Pandas. Function to clean and prepare COVID data frame for analysis. Takes raw data frame as parameter. Columns list defines which fields to keep from original data: country name, total cases, deaths, recovered count, and active cases. DF, columns, syntax selects only specified columns, dropping all others. Dropna removes any rows containing null or missing values to ensure data quality. Sort_values, Cases, ascending equals false. Orders data frame by total cases in descending order, putting most affected countries first. Reset_index. Drop equals true. Resets row indices to sequential numbers and drops old index. Returns clean data frame ready for visualization. Efficient data cleaning pipeline in just a few Pandas operations. Now the fun begins. Creating stunning visualizations. Matplotlib is where magic happens. We're not just making charts, we're telling stories with data. Each visualization type serves a purpose. Line charts reveal trends over time. Bar charts compare categories. Pie charts show proportions. The key is choosing the right visualization for your message. Here's our first visualization, a bar chart of top 10 affected countries. We create a figure with specific dimensions using subplots. Then we use the bar function with our data. The color gradient makes it visually appealing. Add labels, a title, and rotate those x-axis labels for readability. Finally, tight underscore layout ensures nothing gets cut off. Professional-looking chart in 10 lines. Function to create bar chart showing top and most affected countries. Takes data frame and optional top underscore in parameter, default 10. Top underscore countries extracts first in rows using head. Method after data is already sorted. Fig and ax created using subplots with figsize sadface 12, 6 for wide chart format. Ax.bar creates bar chart with country names on x-axis and case counts on y-axis. Color parameter uses color map plt centimeter reds with np.linspace to create gradient from light to dark red across bars. Set underscores label and set underscore label add axis labels with bold font. Set underscore title adds descriptive title with variable top underscore in value. plt.sticks rotation equals 45, ha equals right. Rotates country names 45 degrees and aligns them right for readability. Tight underscore layout prevents labels from being cut off. plt.show displays the final chart. Professional visualization with gradient colors and proper formatting. Look at that. A publication-ready chart that clearly communicates which countries have the highest case counts. The color gradient immediately draws your eye to the most severe cases. This is the kind of visualization that gets shared in boardrooms and research papers. And you just created it with basic Python. Next up, a comparison visualization. This creates a grouped bar chart showing cases, deaths, and recoveries side by side for each country. The key is setting the X position for each group correctly. Numpy's arrange creates our positions, and width controls bar spacing. 3 different colors differentiate our metrics. The legend ties it all together. Function creates grouped bar chart comparing 3 COVID metrics for top N countries. Top variable extracts first N rows from sorted data frame. X created using np.arrange, len, top, generates evenly spaced positions for each country group. Width variable set to 0.25 controls individual bar width and spacing between groups. Fig and ax initialize plot with figsize sadface 14, 7 for wider display. First ax.bar plots cases with X position shifted left by width, red color, hashtag FF6B6B. Second bar plots deaths at center X position, teal color, hashtag 4ECDC4. Third bar plots recovered shifted right by width, mint green color, hashtag 95E1D3. All 3 bars have label parameter for legend. Set underscores label and set underscore label add axis titles with bold font. Set underscore title adds main chart title with larger font size equals 16. Set underscore sticks, X, positions labels at center of each group. Set underscores tick labels adds country names rotated 45 degrees. Legend displays colored key for 3 metrics. Tight underscore layout prevents overlap. This grouped bar pattern excellent for comparing multiple metrics across categories. Quote, data visualization is not just about making pretty pictures. It's about revealing truth hidden in numbers and making complex information accessible to everyone. Dr. Emily Chun, Data Science Lead at MIT. This is the transformation you just achieved. On the left, raw, meaningless numbers in a spreadsheet. On the right, clear, actionable insights that anyone can understand. This is why data visualization matters. This is why companies pay top dollar for this skill. Let's talk impact. Python developers with data visualization skills earn 45% more than those without. The global data visualization market is valued at $8.9 billion and growing. On average, visualized data is processed 60,000 times faster by the human brain. And here's the kicker. 85% of data science job postings require visualization skills. You're learning an in-demand skill right now. Now we bring it all together. A complete dashboard combines multiple visualizations in one cohesive view. We'll use Matplotlib's subplot functionality to create a 2x2 grid of charts. Each quadrant tells part of the story. Together, they provide a comprehensive view of the COVID situation. This is Dashboard Design 101. This is our master dashboard function. We create a figure with 4 subplots arranged in a 2x2 grid. Each subplot gets a different visualization: bar chart, line chart, pie chart, and scatter plot. The tight underscore layout call ensures proper spacing. Savefig exports our dashboard as a high-resolution PNG. One function, complete dashboard. This is the code that impresses interviewers. Master function creates comprehensive 4-panel COVID dashboard. Fig initialized with figsize sadface 16, 12 for large display. plt.subplot 2, 2, 1 creates first subplot in 2x2 grid, top left position. Ax1 contains bar chart of top 10 countries by total cases using red color. Tick_perms rotates x-axis labels 45 degrees. Ax2 subplot, top right, first calculates death_rate as percentage using vectorized pandas operation. Largest, 10, death_rate, finds countries with highest death rates. Bar creates horizontal bar chart in teal color. Ax3 subplot, bottom left, creates scatter plot comparing recovered versus active cases for top 5 countries. S parameter sizes bubbles proportional to total cases divided by 1000 for scaling. Alpha equals 0.6 adds transparency, mint green color. Ax4 subplot, bottom right, creates pie chart of global status. Total calculated using df.sum to aggregate all countries. Sizes list contains active, recovered, deaths totals. Colors list matches pie slices to consistent color scheme. Autopt equals %1.1 f%, displays percentages with 1 decimal. Tight underscore layout prevents subplot overlap. Savefig exports dashboard as high-resolution PNG, DPI equals 300. Complete professional dashboard in single function call. Let me show you what we just built. This is your complete COVID-19 dashboard. Top left shows the hardest hit countries at a glance. Top right reveals which nations have the highest death rates, crucial for understanding healthcare system strain. Bottom left compares recovery versus active cases, with bubble size indicating total impact. Bottom right gives the big picture, the global split between active, recovered, and deceased cases. For charts, countless insights. Speaking of insights, let's break down what makes this dashboard effective. The data flows from specific to general. We start with individual countries, then compare metrics, then show relationships, and finally present the global picture. This is deliberate dashboard design. What you've actually learned. In just 12 minutes, you've mastered an entire data science workflow. You can now fetch data from APIs, clean messy datasets, create multiple visualization types, design comprehensive dashboards, and export professional quality graphics. These aren't just Python skills, they're career skills. Companies are hiring for this exact skill set right now. The code from this project is available in the description below. But wait, we're not done. Want to take this further? You can add time series analysis to show how cases change over weeks. Implement geographic mapping to visualize spread by region. Add interactive filters so users can explore the data themselves. Connect to live APIs for real-time updates. The possibilities are endless. This is just your starting point. Every data scientist started exactly where you are now, with a single project. The difference between someone who dreams about data science And someone who becomes a data scientist? They build projects. They get their hands dirty. They make mistakes and learn from them. You just completed your first real project. You're not a beginner anymore. You're a builder. Quote, "The best way to learn data science isn't through theory. It's by building real projects that solve real problems. Each project makes you better." Andrew Ng, founder of deeplearning.ai. Here's what your data science journey could look like from here. Each project builds on the last, adding new skills and complexity. In 6 months, you could go from this COVID dashboard to machine learning models predicting future trends. The path is clear. You just need to walk it. Let's talk about the opportunity ahead. There are over 11 million data science jobs expected by 2026. The average data scientist salary is $124,000 per year. Python remains the #1 tool used by 83% of data professionals. And the best part? You just proved you can do this. These aren't just statistics, they're your future possibilities. Before you go, I want you to do something. Share your dashboard. Post it on LinkedIn. Send it to a friend learning to code. Put it in your portfolio. Why? Because sharing your work does 2 things. It solidifies your learning, and it shows the world what you can do. Your next opportunity might come from someone seeing this project. Don't hide your wins. Celebrate them. You're a data scientist now. Act like it. Thank you for building with me today. Remember, every expert was once a beginner who refused to quit. You've taken the first step. Now keep going. The next video in this series covers machine learning for house price prediction. It's even more exciting than this one. Hit subscribe, turn on notifications, and I'll see you in the next project. Keep building. Keep learning. And remember, learn data science, one project at a time.